welcome back. In the third part of this four-part session on capital budgeting, we're going to take a look at the modified internal rate of return. We'll also take a look at some of the other methods that are used, including things like payback and profitability index. We saw in the previous video that the internal rate of return comes with three basic problems. The first problem is the reinvestment rate. We have the crossover rate, and then we have a special case where there may be no distinct solution or multiple solutions. One of the tools that was developed probably during the 1990s was the modified internal rate of return as an alternative because of the particular issue that we had with the reinvestment rate problem. We find that it works with other things as well, helps us to solve some of those other issues. Essentially, the modified internal rate of return is just the internal rate of return with an extra assumption, the assumption that we don't have to use a single cost of capital. It avoids the problems of multiple internal rates of return and the indistinct solution that we mentioned earlier. It also allows us to change the assumption that reinvestment is at the internal rate of return by allowing us to assume that reinvestment of the cash flows happens at opportunity cost, the weighted average cost of capital. We know that managers like using the internal rate of return for comparisons because it provides us information in percentage terms, but also because it avoids the issues of calculating the weighted average cost of capital. The downside of the modified internal rate of return is the calculations are a little bit daunting. If we take a look at the overall formula for the internal rate of return, we see that essentially the modified internal rate of return, it requires the comparison of the future value of positive cash flows and the present value of negative cash flows. The future value of the positive cash flows is done using the reinvestment rate, the specified weighted average cost of capital. And the negative cash flows are going to be valued using a different or separate finance rate. This calculation can be done in stages, and an example that we have uses four cash flows. We have an initial cash flow of minus 1 million, a second period cash flow also of minus 5 million. Then in the second period we have 6 million in positive cash flows, and the final period we have 2 million in positive cash flows. So we would calculate or we could calculate this model with those numbers as minus 1 million and then the present value of 5 million discounted at R1, our finance rate, and then the second cash flow would be 6 million discounted back to the present at the reinvestment rate R2, and then the third cash flow 2 million discounted back to the present again at the reinvestment rate R2. We have two unknowns. It's going to be difficult to solve this without doing some extra steps. If we assume that we have a finance rate of 10% and a reinvestment rate of 12%, we can solve this in, well, essentially three stages. In the first stage, we calculate the present value of the negative cash flows using that finance rate of 10%. So our first cash flow happens today. It's an investment today, so we don't have to worry about discounting. It's just negative $1 million. Our second cash flow is going to be received in the first cash flow period, the first discounting period, and that's minus 5 million discounted at 1 plus the finance rate. So relatively simple calculation. The total value of these numbers would be 5,545,000, and of course they're both negative, so that's a negative value. Then we calculate the future value of our cash flows. Now remember, the future value is the value taken from the future looking backwards, and so in the third period, or the second discounting period, we're going to receive $6 million, and we're going to use the reinvestment rate of 12%. So the 6 million can be reinvested at 12% back in our business or in an equally risky investment. And in the very last period, of course, that $2 million is going to be taken in the future, so we just take the straight $2 million. So 6 million times 1 plus the discount rate to the first power plus 2 million is going to give us a future value of 8720. We plug those into our formula, and that means that in the numerator we have the future value, 8720, and in the denominator we have the negative of the negative. So we said it was minus 545, and we're going to take the negative value of that according to the original formula. And we take the third root of that, and so that gives us a value of 1.1629. Now we want to treat that as a percentage because that would be consistent and not as a factor. So we subtract 1 from that, and that gives us the modified internal rate of return of 16.29%. As I said, it's a little bit more work. Now we can do the calculations with with our calculator in about 4 steps. We can also use the spreadsheet to do that kind of a calculation as well. So, for example, with the spreadsheet calculations, for our original project, we had $100 million original cash flow followed by 10, 60, and 80. Nothing special about this. We could solve this using internal rate of return. But in this case, we're going to use the finance rate for the negative cash flows and the reinvestment rate for the positive cash flows. So we use 10% for the first value of minus 100, and then 12% for the 10, the 60, and the 80. We can solve this using one of the Excel functions, the MIRR function. And we simply do that by typing in equals MIRR. And it's going to prompt us for the values, and those are found in cells B3 to B6, the blue box that we've got on the screen. The finance rate is E2, the red box, and the reinvestment rate is E3, the purple box. And that gives us a value of 16.9. As I say, nothing fancy, nothing difficult about that. We could also calculate this in about 4 steps using the calculator by calculating the future value of the negative flow, of the positive flows, the present value of the negative cash flows, and then solving afterwards. But this approach, the spreadsheet approach, is clearly simpler. Essentially, the modified internal rate of return is the discount rate that causes the present value of the project's terminal value, the values from the end, to equal the present value of the costs. And our terminal value is found by compounding the inflows at our reinvestment rate, the weighted average cost of capital. The modified internal rate of return assumes cash inflows are reinvested at our weighted average cost of capital, which, as we said at the beginning, is a much more reasonable assumption than to use the internal rate of return. It provides us with a single solution, a unique solution, which gets away from that problem that we also saw, and we would accept every project if the modified internal rate of return is greater than our weighted average cost of capital. So, for example, solving our problem with the cash flows that we saw from the very beginning, 100 million invested, then we earn 10, 60, and 80. We would take the, if we had a reinvestment rate of 10%, or a weighted average cost of capital of 10%, we'd find the future value of our cash flows. So 10 million times 1.10 to the first power would give us 121.1. 60 million times 1.1 would be 66 million, and $80 million in 3 years' time would give us a future value of $80 million. So the terminal value of our inflows would be 158 million. The present value of our outflows minus $100 million. So next we would have to find a discount rate that equates the present value and the future value. So if we take 158.1 and divide that by 1 plus the modified internal rate of return to the third power, that rate would be 16.5. Now, again, a simple solution. When we have non-normal cash flows, if we don't have a single unique solution, if we use an approach like this, we get an answer, even if it is not a great answer, not the answer that we'd want to see. The present value of our outflows at 10% would be $4.9 billion. The terminal value of our inflows would be $5.5 billion. So our modified internal rate of return is 5.6%. Would we accept this project? Well, no. We'd reject it because the modified internal rate of return at 5.6 is less than the weighted average cost of capital of 10%. And the modified internal rate of return, if the modified internal rate of return is less than our weighted average cost of capital, the NPV will be negative. And we saw earlier that we could solve this with a calculator, and it produces a negative NPV of $386 million. Definitely not a good project. So the modified internal rate of return has some advantages. It allows us to use the internal rate of return approach that managers tend to like. But it adds the rigor of the NPV method as well. Still, in terms of a hierarchy of methods, NPV is still the best. Modified internal rate of return, second best. Even though a lot of businesses will put a lot more emphasis on internal rate of return and the modified internal rate of return. Yet there are other methods that are in use as well. We consider these methods to be complementary. In other words, you should use NPV, but you can also use some of these other methods. And that's where we start to talk about things like profitability indexes or indices and payback methods. Now, profitability index is often used to rank different projects. Essentially, a profitability index is the present value of the future cash flows divided by the initial cost. It's also described as a measure of bang for the buck. It's a scaled version. In other words, it puts all projects on the same scale. So for every dollar that's invested, how many dollars do we expect to get back? In other words, the bang for the buck. We'd accept any project if our profitability index is greater than 1. In other words, we get $1 back for $1 invested, or the present value of $1 back for every dollar invested. If our profitability index is equal to exactly 1, that's equivalent to saying the NPV of the project is equal to 0. If the profitability index is greater than 1, our NPV is greater than 0. If you consider, for example, the project we've looked at so far, Project L, we saw that the cash flows that we're going to receive, the present value of the cash flows, 9 million, 49 million, 60 million, the sum of those is $118.8 million. That's the cash flow that we're going to receive. The cash flow going out was minus 100. So a simple calculation, the present value of our future cash flows, 118.8, divided by the initial cost, 100 million, gives us a profitability index of 1.18. Now, Project S was a little bit better because it gave us a return of 1.19. If these were independent projects, we'd choose both. If they're mutually exclusive, which one would you choose? The one with a number of 1.18 or the number of 1.2? On the face of it, Project S looks better. It has a higher profitability index. But here's the problem. These are scale independent. Now, what if Project L was a $1 billion project? That means you'd make $119 million of profit, of positive NPV. What if Project S was a $100 project? Your total return would be $1.20. You'd get a $20 return on the project. What would you rather have, 118 million or $20? So it doesn't take into account the value of the total value of the project. It's scale independent. So the thing that makes it useful is also the thing that becomes a problem. Make sure you remember that, because managers like to see a profitability index. Another tool that managers like to see is a payback and payback models. Essentially, it's the number of years that it takes to get your money back. If you decide that I'm going to put up a new building and I'm going to collect rent from my tenants, and I'm going to get paid back in 20 years. In other words, the rents will provide me with a return in 20 years. If you think that that sounds good, you'd go ahead with that project. What if the lease on the land was only good for 15 years? Well, clearly you'd want to make sure that you got your money back before the lease ended, so it wouldn't be a good project. Or perhaps it's a project that'll have a life and cash flows that go for the next 60 years. Getting your money back in 20 years, when you've got 60 years, would seem like a reasonable kind of bet. If you're operating in a developing country, in an unstable political environment, and you could lose your property within the next 10 years, the 20-year payback period would not seem reasonable. You would want to charge much higher rents in order to get a higher and earlier payback. So it's essentially a measure of the number of years required to recover your capital. Companies may have a benchmark that they use for payback period. In other words, we'll expand into a new market, we'll make an investment of almost unlimited amount of money as long as we get our money back within 3 years. That can be part of the requirement. Yes, we want a positive NPV, and we'd like to see an internal rate of return greater than our weighted average cost of capital. Maybe we have to have a profitability index greater than 1.2, but also we might have a payback period of 3 years or 5 years as a policy item. So we would reject projects that have a longer payback than that standard payback period. The other advantage of payback period is the calculation is very simple. And there are a couple of problems. We'll come to those in a minute. Calculation for our project, the same project we've looked at so far with a 100 million investment, then 10, 60, and 80, essentially it pays back in about 2.4 years. And we calculate that by starting off by saying at time 0, we make our investment and we're 100 million in the hole. In period number 1, we earn $10 million, so we subtract the 10 million from the 100 million, and that says we're only 90 in the hole. Next period we get 60 million, we subtract 60 from the 90 that we're in the hole, and now we're only 30 million in the hole. So that's where we are in here. We're still 30 million in negative. The next period we're going to make 80 million. Now, 80 million is definitely greater than 30, so we're going to be out of the hole somewhere between the end of year 2 and the end of year 3. And we can calculate precisely what point during year 2 that we're going to get out of the hole by using interpolation. And simply interpolation is to take the 30 that we need to earn and dividing it by the 80 that we're going to earn during that period. And that's 0.375. So 0.375 of the way through the year, we're going to break even. You could even take that 0.375 and multiply it by 365 to tell you which day of the year you expect to break even. So perhaps sometime during May of the 3rd year, we're going to break even. That is our payback method. Now, of course, there are problems with this. It doesn't take into account things like the discount rates. And so that could be a problem for us. We'll come back to that in a minute. If we look at Project S, on the other hand, remember it's the one with the quicker payback. That's why it's called S for shorter. We have a same investment, then we earn 70, we earn 50, we earn 20. 100 million in deficit, and we add 70 to that. That means we're only 30 in deficit at the end of year 1. Then we earn 50, and we're going to be 20 ahead at the end of year 2. And then we're going to earn another 20, so we'll be a total of 40 ahead at the end of year 3. But what we're particularly interested in is our break-even. And our break-even is in between year 1 and year 2, where we go from negative to positive. And so 30 divided by 50 would be 3/5 or 0.6 of a year. And so 0.6 of the way through our first year of the positive cash flows, we're going to break even. Our payback is much earlier than it would be for Project L, which is pretty much the design of those particular examples. Now, the strengths. It provides a measure of risk because risk increases with time. And it also is about the cash flow because it means we're going to go positive in terms of our cash flows earlier. So it's also about liquidity. It's easy to understand. It's easy to communicate. Entrepreneurs love this term because it's something that they easily understand without any kind of a finance background. And sometimes that seems like it's sufficient, although probably it isn't. Some of the weaknesses, well, it ignores the time value of money. Time value of money, or a discount rate affected cash flows, are essentially about applying risk to return, and so we're completely ignoring the level of risk. Two projects, one with much higher risk, would be accepted in terms of their order of payback, and that would not necessarily give us the highest NPV. It could destroy shareholder value. It also, very importantly, ignores any cash flows that we receive after the project is over. So if we get our payback in 3 years, but the project goes on for 20, we might not choose that project because another one pays back in 2 years, even though it only runs for 3 years. So we could miss out on the best possible project. NPV, internal rate of return, would spot those issues, but the payback period doesn't. Now, we can fix part of that by using a discounted payback. Although this gets away from the idea that we want to keep things simple to explain to our boss who doesn't understand present value. We can use discounting here, so instead of using the original numbers of 100, 10, and 60, and 80, we would use the present value of those numbers. So minus 100, 9, 49, and 60. Those are discounted at 10%. And then we use the accumulation approach on the next stage. So 100 million in the hole, add back 9, puts us 90 million in the hole, add back 49 puts us 41, and then add back 60 and it makes us positive, and we can simply take at that point the interpolation of 41 over 60, and that gives us about 0.7 as our interpolation factor. So 2.7 years into the project will break even. So in conclusion, after having looked at NPV, we've looked at the internal rate of return, the modified internal rate of return, the profitability index, the payback period, the discounted payback period. After looking at all of these methods, these are some of the things that we know. Our quantitative methods provide us with lots of information, but they can't be used for a simple accept-reject decision in our capital budgeting process. Qualitative factors have to be considered as well. NPV is considered by all academics and by all textbooks as being the best method, and is considered, or we tell people that it's the single most important method for showing absolute profitability. However, we know that in practice many companies, especially for engineering projects, tend to use internal rate of return. Academics would say it's the second best, but in some businesses it's actually the one that's used most commonly. The modified internal rate of return gets around some of the problems that we see with the internal rate of return, including those problems of reinvestment rate, the problem of the crossover rate, and also the problem of the indistinct solution. Other methods like profitability index are commonly used. Payback in particular is still used, especially by entrepreneurs. Now, that covers the first part of capital budgeting and the material that we need to cover for this course. However, there's some special cases that I would encourage you to take a look at in the next video.